Okay, if an item is discounted 20%, the sale price is what percent of the original price? So, the discounted price is the percent of the whole price that you don't have to pay, right? It's the percent that goes away. The sale price is the price you pay. So it's the percent of the whole that you do pay, the sale price. We want to know what percent the sale price is. Well, is the original price the whole? Yes. Is the original price the whole? Yes. Always. Now the whole thing is always equal to what percent? Yes. If we're taking 20% off, what can I subtract? 20%. Good. And what would I end up paying? 80%. So 80% of the original price is the sale price. So let's use that with an actual example. If the original price of the item is $400, what is the dollar amount of the discount? Okay, so here's what's different about this lesson. We have to pay close attention to what part of the problem the answer is asking us to solve, because we have a percent discount and we have a percent for the sale price. Okay, so we're going to label everything. Let's write our whole part in percent. What's the whole? $400. We don't know the part, right? We want to know the part that is the discount. What percent is the discount? Alice, what percent is the discount? 20%. Why is it not 80%? Turn and talk with your neighbors. Turn and talk with your group.
It's because that's the original price. If an item is discounted, it was 20%.
Good. Bring it back in 3, 2, and 1. Good job. Amaya, explain to us why it's 20% and not 80%.
Because whenever it was only 80% because it was taking 200 off 100. Right now we're taking 20% off 100.
Right. We want to know the amount. I see what you're saying. We want to know the amount of the discount, not the amount that's left after the discount. That's the sale price. We want to know the discount, not the sale price. And up here it says the discount, the item is discounted 20%. So yeah, 20%. So how do we find this? What fraction can I start with? Coral.
20 over 100?
Mm-hmm. And why'd you choose that fraction?
Because it can be over 100. Like
Yeah, we can make a complete fraction out of the percent. We can't make a complete fraction out of the part and whole because we don't know the part. Okay? The whole goes where? Top or bottom? The whole goes on the bottom. The whole is the denominator. And the whole in this problem is $400. Can I turn 100 into 400?
Yes.
Yeah, so we're not going to reduce. We're going to multiply by
4.
So what do I do on top?
Multiply 4.
And I get?
80.
So how much money did I save? $80. How much is the sale price? Okay, there's 2 ways to do this. If, for example, we did not do the first part and we were only asked what the sale price is, we could write that the whole was what? $400. The part we want now is the sale price. We don't know it. We want to find that part. The percent that is equal to the sale price is what?
80.
Yes, 80%. Because the sale price is the percent that we pay after the discount. Go ahead, Unique. Go ahead. So what fraction do I start with this time, Braulio? 80 over 100. 100, right? Because you can't put the percent over the whole. You can put percent over 100. You can only put the part over the whole. We need for the whole to be 400. The whole is the denominator or numerator? Denominator. Can I turn 100 into 400?
Yes.
Sure, I don't need to reduce. I need to multiply by.
4.
What do I do on top? And you get?
32.
So the amount that I pay is... Okay, here's the other way you can solve this question. Since we did this part first, we found the amount that we saved. If we're then asked how much the sale price is, the amount that we pay, we can just subtract the amount we saved from the original price, right? But we did it this way first because I wanted you to see that if we didn't have this information, that you can find it the same way as you found this part. So up here we found the part we saved. Down here we found the part we paid. Yes, Kai?
I don't get this at all.
Okay. We're going to get lots of practice. Okay. And can you tell me kind of like where you're getting lost?
Everything.
Okay. That's okay.
Just like I don't understand.
You feel that way too? A little bit? Okay. Now, let's label some things. Because now, like we said in our last example on lesson 27, we're dealing with money now, right? This is called comparison shopping when we talk about discounts and sale prices and all that. So let's label some things that are always the same. Kai, track the board. Let's label some things that are always the same. Your original price when we're comparison shopping is always the whole. Your original price is the whole. The amount you saved. So here's what's different about these problems from the problems we've been doing in lesson 26. The amount you saved is a part. The difference now is that we also have an amount we can pay. The amount you paid is another part, right? We have two parts. We have the amount you saved, okay, which is the part we subtract. And you have the amount you paid, okay, the part that you paid. So when we're talking about percent in comparison shopping, we also have two percents. We have the percent that you saved. The percent you saved is the discount. That means that percent is the amount we take off. The percent you paid is the sale price. Whatever you paid is the sale price. Now, when you're putting these problems together, all that matters is if you're solving for this, you use this percent. They go together. Percent paid can help you find part paid. If you're solving for the part you saved, you use the percent saved to find that part. These two go together. These two go together. You can't use the percent you paid to find the percent or the part that you saved, right? We'll do some more examples. So turn the page to 148. And just quickly before we get started on 148, track me. I'm waiting on a few. Danielle, Messiah, track me please. Brilliant. Okay, this is important. I understand that this is a lot. I understand this is new. I understand this table is super overwhelming, okay? Don't get discouraged. It's not over, okay? If you're lost right now, that is okay. We just learned this. Don't get discouraged, Okay, we're about to get a lot of practice with this table, so let's go ahead and do it together. Okay, so for each row of this table, there's a different item, right? TV, sneakers, video games, right? And over here, we have original price, sale price, discount, percent saved, percent paid. Ooh, that's overwhelming, right? Okay, it doesn't have to be. Here's why. Remember what we just wrote out on page 147, all those things that are constants? What can we call the original price?
Whole.
Yeah, something we're more familiar with. It's the whole. The sale price is part of the whole, right? Is it the part you saved or the part you paid?
Paid.
Yeah, the sale price is the part you paid. The amount of the discount, is that the part you saved or paid?
Saved.
Yeah, that's the part that you saved. You didn't have to pay it. So, when you're dealing with the part you paid, you're using the percent you paid. When you're dealing with the part you saved, you're using the percent you saved. Okay, because the percent that you saved out of the whole will give you the part that you saved, the amount in dollars. So let's do an example to show you how this works. So again, I'm just going to write like we always do, whole, part, and percent. Whole, part, and percent. So for the television, I'm going to write TV here. For the television, what's the whole? We don't know. That's exactly right. What's the part? Well, there's two parts, right? Let's go with the part we know. What part do we know? $800. And that's the part we paid. We paid $800. So the percent paid needs, the percent that we use needs to be the percent paid. Well, right here we don't have the percent paid. How can we find that? Isaac? Yes. The percent saved and the percent paid together need to equal 100 because the whole price is 100%. So what's 100 minus 20?
80.
Yeah, 80. 80%. So the percent paid is 80%. And I'm just writing paid so I know I'm using the correct numbers to compare. So now it's just like every other problem we've solved. Which fraction should I start with? Which fraction should I start with, Darlie? The percent, right? Because I don't have the part and the whole. So I'm going to start with the percent over 100. I need for the part to equal 800. The part goes where? Top or bottom? Not yet. On the top. Can I convert the numerator here to 800 pretty easily? Yeah, so I'm not going to reduce. I'm going to what? By 10. So what do I do to the bottom? And I get? Now I know that the whole original price is $1,000. Okay, where am I losing you? Pause, pause, pause. Where am I losing you? Shh. Okay. We're using logic, right? We're using a lot of logic, which means you decide based on what's reasonable, what steps to do next. Okay, so I understand that can be overwhelming. Usually, you're used to memorizing steps and just doing those steps. Okay, now I'm giving you a bunch of information and I'm saying figure it out like a puzzle. Okay, you can do this. You absolutely can do this. Please remind yourself that this is brand new. This table is enormous. It looks like a lot. All we need to do is break it down. So like I said, we're only looking at this first row for television. Okay, so just ignore this mess. I don't need this. I'm going to draw this for you so you can see it visually, okay? Yes, sir. How I got from 800 to 80? Okay. Here's how it works. Let me show you. So, I have a whole, this whole price. Okay, we're going to look at it like a number line, right? This is our model we've used before. Yes, we're looking at it like a number line. The whole thing, we don't know what that's equal to. We want to find what number the whole thing is equal to. We do know that the whole thing is equal to 100%, right? That's always true. All of the model is 100% of the model. And none of the model is always 0%. None of the quantity is 0%, right? So here's what we know so far. This is how you set up all your diagrams when you don't know the whole. Okay, yes ma'am?
Can we draw that?
You can, but what I'm trying to do right now is just show you how this looks conceptually because it's kind of hard to understand with just all the numbers floating around. Go ahead. Okay, so here's our model. Now, what we know is that we paid $800 for this TV. Okay? We paid $800 for this TV. We also know that that $800, the part paid, is equal to 80% of the whole. We know that because these two percentages just have to add up to 100. Because the percent you saved and the percent you paid, if you put them back together, you'd have the whole, which is 100%, right? So if we know that 80% of the whole is $800, we can label that on our diagram. If I want to put 80% on our diagram, what could I count by? What could I count by down here to get to 80%? 20s. 20, 40, 60, 80, 100. Let me label that. And what did we say? 80% of the whole price is equal to what we paid, which was $800. Now, we can see from our model that the percent we saved, we didn't pay this part, is how much? This is worth what percent? Between 80 and 100, yes, 20%, right? We saved 20%. Okay? We're trying to find what 100% is equal to. We know 80 is equal to 800. Remember, when we don't know the whole, we're going to cover up the rest and pretend like the part is the whole. If 800 is the whole, I have split it up into 1, 2, 3, 4 parts. So what should I count by on top? I've split 800 into 4 parts. I should count by 200. So 200. 800. Okay. So if I had added that 20% that I saved back to the amount I paid, I would get the original price, the whole price, and it would be $1,000. Thumbs up if this is helpful. It's okay if it's not. Show me if you're more confused. Okay, and somewhere in between? Okay, hands down. It's okay, we have a healthy mixture. That's okay. So, if using the math is the most helpful for you, then just use the math. But if the question asks you to use a model, check your work with a model. Use whichever method makes more sense to you first. Use the other method to check your work if the question asks you to. Kai.
So basically what you're telling us to do is like trick your brain into thinking that you're checking the word.
Yes. Yeah. Because look, for me, because this is how I learned math, the numbers by themselves make a lot more sense to me. I could see how for a lot of people the diagram would make more sense. You start with whatever you know best. Whatever helps you figure out the answer easier. Check your work with the other method. Okay? That's just called using the most reliable method. Whatever one's easier for you is the most reliable one for you. Okay? So, up here, the amount of the discount. If the original price was $1,000, but I only paid 800. What amount was discounted? What part did I save? What was it? How much, Nathaniel? $200. And how did you know that? Because
you gotta subtract 100.
yeah, we're just taking the whole price minus what we paid to get what we saved. Okay? Now, we'll worry about this more later. I would like you to please close your books. Roll leaders, do your jobs.